Yeah, let's look at a few more numericals now. The other class we have actually looked at or computing all these probabilities except for the gamma. See, gamma, there are two ways of doing. Either you can use your integration gamma formula and then try to do it, try to solve the expression. But most of the times, what is expected is in the exam, you take the approximation of gamma from the chi-square distribution itself. See, we have said that if the gamma is in this gamma distribution, gamma of alpha comma lambda, if this lambda is equal to half, we said it will boil down to chi-square distribution with degrees of freedom 2 alpha, double of this. That is how the relationship is. But in the question, he is giving that lambda equal to 2. He is not giving it as half. So what you can do is you can slightly make a different transformation. So when someone is asking me for x less than 6, you try to do it as 2 lambda x. So if you do this 2 lambda, which is which means in this case you don't see if this has to be half instead of 2, it's as good as you are multiplying it by 4. You are multiplying that half by 4. So it's as good as if instead of half, if anyone is giving you any other value for lambda, the simple thing is instead of x, you try out for 2 lambda x. So it's as good as saying p of x is less than 6 is same as saying 2 lambda x. You multiply both sides with 2 lambda. 2 lambda x is less than 2 lambda 6. So 2 lambda x will take a chi-square distribution because they are already talking about lambda equal to half now once you have multiplied it by 2 lambda. So 2 lambda x is following a chi-square distribution. So it's as good as saying chi-square less than 2 lambda x. Lambda is 2 in our example. 2 into 2 into 6, 24. So chi-square less than 24. What is the degrees of freedom for this? 2 alpha. Alpha is given as 6. So 12 degrees of freedom. What is the probability that a chi-square with 12 degrees of freedom is having a value less than 24? I can very well pull that out from our tables, right? So looking at it, 12 degrees of freedom, and he is asking for value less than 24. And if we are seeing this is less than itself. So 24, this is the 24, 12 degrees of freedom, 0.9797. So there is a 97% or 98% chance that this value is less than, the chi-square value is less than 24 with 12 degrees of freedom. So if gamma is 6 comma 2, see gamma is 6 comma 2 is nothing but what is the mean of it? Mean is alpha by lambda, which is 6 by 2, 3 only. And the variance is alpha by lambda square, which is 6 by 4, 1.5. So what you can very well say is he is asking for value less than 6. Almost all the values should be less than 6 itself. That's the reason we are getting the answer as 97 or 98%. So even the most of the times for gamma related questions, instead of using integrations and doing all those things, our exam wise, it's very much appropriate to go with the chi-square approximation. How do I do the chi-square approximation? As I said, whatever is the gamma distribution that he is giving. The simple thing, if the lambda is already half, you directly take it as chi square of 12. You directly take it as chi square of 2 alpha. But if the gamma is not half, if it is anything else, if the lambda is not half, if it is anything else, what you do is you take 2 lambda x. That will follow a chi square. X will not follow a chi square. 2 lambda x will follow a chi square distribution. So in this case, x will not follow chi square, but 4x will follow a chi square distribution. So keep doing everything with respect to 4x. Right? So 4x will follow a chi square distribution. So which means if at all I am looking at p of x less than 6, I should look out for p of 4x less than 24, because chi square 4x will follow a chi square distribution. So I have to look out for 4x less than 24. And when I say 4x less than 24, it follows a chi square distribution with 2 alpha degrees of freedom. Right? So the moment you are able to solve all these questions, it becomes more comfortable. Right? See, the major question that can come out is, yeah, if something is following some kind of a distribution, what is the chance or what is the probability of something else occurring? That's a typical question which you can expect, which would fall into one of the 6 kind of categories for us. Now let's look at the next question. A random variable has a log normal distribution with a mean 8. The mean of the log normal distribution is 8. It's not mu. Right? Mean of a log normal distribution, as we have seen, when you go back to your formulas, the mean of the log normal distribution, go back to your formulas. The mean of the log normal distribution is e power mu plus half sigma square. Right? It means that e power mu plus half sigma squared is equal to 8. Right? And variance is this one, e power 2 mu plus sigma squared into e power sigma squared minus 1. So let's solve this numerical one, which will get a clarity on the whole stuff. The a random variable is log normal with a mean 8. E power mu plus half sigma squared is equal to 8. And variance is 3, which is nothing but e power 2 mu plus sigma squared into e power sigma squared minus 1 equal to 3. So these are the numbers. So based on this, what the simple, I need to find out mu and sigma before I actually do any kind of calculation. So how am I simplifying it? This is nothing but the mean square, the square of the mean. So this I can write it, this part I can write it as 64 into e power sigma squared minus 1 equal to 3. So from here I can get the value, e power sigma squared minus 1 is equal to 3 by 64, and e power sigma squared comes out as 1 plus 3 by 64. So 3 by 64, 1 plus 3 by 64, that is e power sigma squared. So sigma squared will become logarithm of that. So logarithm of this is sigma squared. So sigma, if I want, so this is the variance of, or this is the sigma squared. if it is following a log normal distribution. Now what I can do, I can substitute here e power mu plus half sigma squared equal to 8. So mu plus half sigma squared equal to log 8. So log 8. So I am saying log 8, right? This is mu plus half sigma squared. So sigma squared I already know. So I can say mu equal to 8 minus half sigma squared. Log 8 minus half sigma squared. So this is log 8 minus half sigma squared, which is giving me that this is mu. So this is the mean of the log of the converted normal kind of a distribution. This is the mean, and this is the variance or sigma squared. Now these two are the inputs I will use to talk about calculate the probability that the value will take, the variable will take between 6 and 10. 6 and 10 means I have to look at between log 6 and log 10. Right? So log 6 is this much. Log 10 is this much. So I want to find out what is the probability that the variable will take the value between 1.79 and 2.3. So I can look at each one of them because the normal distribution typically gives the left hand side. Now this becomes a normal distribution with mean 2.05 and variance 0.04. And probably the standard deviation of it is nothing but the square root of this 0.21. Now 1.79 if I want. So for 1.79 what is the area? 1.79 minus the mean. So here only I will compute. The area is x minus mu by sigma. So 1.79 minus mean divided by sigma, standard deviation. So what is the value of z? That is less than minus 1.23. This is the standard normal distribution whose value should be less than. What is the probability that it is less than minus 1.23? And we know that normal distribution tables don't give minus less than 1.23, less than minus 1.23. So it's as good as saying greater than 1.23. Check out in the normal distribution tables for less than 1.23 and take a 1 minus of that. Right? So here I'll directly use the formula just to understand it. So it is saying this value less than minus 1.23 is 10%. The same way I'll do for 2.3. I need 2.3 minus 2.05 divided by 0.21. So I need less than 1.14. I can directly look at it from the table and I'll get less than 1.14 area. So here again I am getting it as norms just of this. So it's an 87.48% area. So this is less than this is 10%, 10.8%. Less than this is 87.48%. So lying between the two is nothing. Yeah. Here the formula did that directly. But when you are using tables, you have to do that. So this is less than minus 1.23, 10%. This is less than 1.14, 87%. So I need between those two. So I am subtracting these two, saying 76% probability that the values will lie between whatever the 6 and 10. Because whenever a log normal distribution is given, we have to convert it into a normal distribution by adopting this kind of a process. right? So you have to clearly see whether he has given mu and sigma squared, or he has given the mean and the variance of the log normal distribution. If he has given the variance of mean and variance of the log normal, you have to actually compute mu and sigma squared from that. Then use it into your normal distribution. That process you should not miss out. Right? Okay. If x denotes a continuous uniform random variable, taking the values in the range -1 to 1. So because it's a uniform random variable, the mean is a plus b by 2 and variance is a minus b whole squared, b minus a whole squared by 12. So a plus b by 2, mean is 0. Variance is b minus a whole squared by 12. 2 squared, 4 by 12, 1 by 3. So if it is a continuous distribution, the mean of that is 0. The variance of that is 1 by 3. Now the other thing what he is saying is, whereas y is a discrete uniform variable, taking -1, -2 by 3, -1 by 3, 0, 1 by 3, 2 by 3 and 1 with equal probabilities. Even the mean of this is also 0, because this is also like there are 7 possible values. The mean is nothing but the first, if it is a uniform distribution, the mean is nothing but the first term plus last term by 2. Again a plus b by 2. So directly here also the mean is 0 only. But the variance n squared minus 1 by 12. Right? Or the simple way we are finding out the variance is expectation of x squared minus expectation of x whole squared. Expectation of x, we have already said it is 0. So all I need to do is expectation of x squared. So I will say 1 into 1 by 7 if I compute like this, plus 4 by 9 into 1 by 7, plus 1 by 9 into 1 by 7, everything squared multiplied by its probability, plus 0 into 1 by 7, fine, 1 by 9 into 1 by 7 again, and plus 4 by 9 into 1 by 7, plus 1 by 7. So how much is that coming out? 2 by 7 plus, here it's almost 4 by 9, 5 by 9, 10 by 9 into 1 by 7. So if I simplify it, it is becoming 1 by 7 into 2 plus 10 by 9. 18 plus 10, 25 by 7. 1 by 7 into 25 by 9, which is almost 25 by 63. How much is this? Now this one is having a, see, both the means are same, whether it is discrete or continuous. Though the average value is the same, but the variances are different. Here the variance is coming out to only 1 by 3. Whereas here the variance is slightly more than 1 by 3. Because if it has been 1 by 3, you would have got 25 by 75. So here it is slightly more than 1 by 3. Which is telling me clearly that in a discrete case, though the continuous and discrete, both of them have the same averages, in the discrete case, you will find that the variance is slightly higher compared to the continuous case. In a uniform distribution, because we have both discrete as well as continuous uniform distribution. So what it is clearly saying is, though the means are same both in a discrete as well as a continuous uniform distribution, what we are seeing is the variance is slightly higher in the discrete case compared to a continuous case. Right? All right. Let's move on to the next one. Yeah, this gives a good clarity on the Poisson. I think we have done it to some extent. The number of claims per policy in a year has a Poisson distribution with a mean 0.8. Poisson distribution mean. What is the mean of the Poisson distribution? Lambda. Right? This, at least from the tables, you should get that comfort level. How do I check it and what values I have to take? So because he is saying it's a Poisson distribution, mean is 0.8, I should be very much comfortable in taking lambda value equal to 0.8. The claims are following a Poisson distribution. Okay, calculate the probability that a particular policyholder makes at least 4 claims in this year. What is the chance of making at least 4? So 4 are above, right? 4, 5, 6, 7, whatever it is, which is nothing but the whole thing minus 0, 1, 2, 3. Probability of x equal to 0, probability of x equal to 1 claim, 2 claims and 3 claims. Right? What is the probability of 1 claim or any of these claims in a Poisson distribution? E power minus lambda, lambda power x by x factorial. This is the probability for 0 claims. Same thing put here 1, probability for 1 claim, 2 claim, 3 claims. Whatever the number that you get, you subtract that from 1, it will say 4 or more claims. That is the probability. So this can address your problem of Poisson distribution. The moment you know the lambda value, right? The moment you know the lambda value, you can very well try to find out what is the probability that it is less than some particular number of claims. Okay. The policy holder in part 1, which is the above, is known to have already made at least 2 claims this year. At least 2 claims he has made. Calculate the revised probability that this policy holder makes at least 4 claims in this year. Now what does it mean? At least 2 claims is already done. So probability that x is greater than or equal to 4 is the earlier question. But now the question is becoming probability that x is greater than or equal to 4 given that x is greater than or equal to 2. He has already made at least 2 claims. He has already made at least 2 claims. So what is the chance that he has made at least 2 claims? If I just subtract these 2, if I only take this part, this is the probability that he has made at least 2 claims. Right? So if I do this entire part, at least 4 claims, divided by at least probability of at least 2 claims, that gives me the revised probability. It is given that he has already claimed 2. So I should not consider the probabilities for that. It goes as a conditional probability distribution for us. Right? So it is like this. So if I say lambda equal to 0.8, right? Probability that he is making at least 4 claims, or at least 4 means I am looking at lambda power x into e power minus lambda divided by x factorial. So there is a 44.9% chance of making 0 claim, like this. Now, which means in isolation, if I am finding out what is the chance of making 4 or above, then it is nothing but the 1 minus of summation of all these 4, which comes out that there is only 0.009 or 0.9% chance that he will make 4 or more claims. Now it is said that he has already made 2 claims. So what is the chance of making at least 2 claims? At least 2 claims, the chance is only this much. At least 2 claims, the chance is 19%. Now, my whole probability of 4, I will look at it in the scope of 19 only. I will not look at it in the whole scope. It's like I am narrowing down the space. When information is given, see, even from the formula, what did we say? P of A given B is nothing but P of A intersection B by P of B. A intersection B, what it is? Greater than or equal to 4 and greater than or equal to 2. What is the intersection of those two? Greater than or equal to 4 only. Right? Any number greater than or equal to 4 is 4, 5, 6, 7, 8. Greater than or equal to 2, 2, 3, 4, 5, 6, 7, 8. The intersection of those two is nothing but 4, 5, 6, 7, 8, which is P of P of greater than or equal to 4 only, divided by P of B, which is greater than or equal to 2. So in this case, so any conditionality that is given, we always work it out through this kind of a formula itself. So this goes like 0.009 divided by this, which will say the probability is 4.74%. Given that he has already, if no information is given, then his chance of making 4 or more claims is only 0.9%. Now if he has already made 2 claims at least, the chances are now higher because he has to still make only 2 more claims. Right? Because he has already done 2 plus, so the chances are going up. That is what is being coming out from this, saying now his chances are 4.7% that he can make 2 more claims and the total number of claims will be more. So you should not look at the sum of these two or something like that. Right? It's so anywhere it is mentioned that some information is given, you should always look at it like a conditional probability kind of a question. Right? You will always look at it like a conditional probability question, apply that P of A given B kind of a formula and then solve it. Right? Now, calculate the probability that a portfolio of 6 independent probability policies give rise to at least 3 claims this year. So now we are talking of 6 policies. Per policy, the lambda is 0.8. So for 6 policies using the Poisson process or using the multiple, for 6 policies I can directly take the lambda equal to 4.8. Even if he is giving per policy, For 6 policies, you can take your lambda to be 4.8. So now he is talking about give rise to at least 3 claims. So which is nothing but it should not be 0, 1, 2. So you can simplify the process now. P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. Now the only thing is lambda will not be 0.8, lambda will be 4.8. You do the same process with lambda equal to 4.8, you will get the required solution. The lambda you can directly multiply for multiple policies because they are all independent policies. So the lambda of 6 policies is the summation of the lambda of each of the policies. It's like that, right? If different policies, let's say the lambda of the first one is 1, of the second one is 2, of the third one is 3. The 3 put together lambda is 6. You can do a simple addition of all the 6 lambdas. So addition of all the 6.8s is nothing but 4.8 for us. Right? Then obtain the probability that there is a wait time of at least 3 months. So 3 months or more between the claims on a single randomly selected policy. So waiting time, as we have said, we will follow an exponential distribution. In any Poisson process, the waiting time between two events, we will always take it as exponential distribution, right? So now for me the objective is, so for this is in terms of years, 0.8 lambda equal to 0.8 is in terms of years. So here also this I have to make it into years, 1/4 year. So the question is about what is the probability that the waiting time is greater than 3 months. So probably I may take it even up to the infinity part, 1/4 to infinite lambda e power minus lambda x. So because this is an exponential kind of a distribution. In a Poisson process, Poisson distribution, the waiting time between the events, I can very comfortably take it as exponential distribution. Now if I do an integration of this, it is nothing but e power 0.8 into e power minus 0.8x divided by minus 0.8. So this I'll do it between infinite and 1/4. So this is always minus is there here. Infinite I can ignore, minus e power minus 0.2. So it is as good as e power minus 0.2. That is the probability. So substituting e power minus 0.2 or finding out, calculating the value of e power minus 0.2, it is nothing but 81%. So there is an 81% chance that there is at least 3 months waiting time. At least 3 months waiting time between the two claims. Because average is only 0.8 claims per year, right? Not even one claim per year. So that's where it is saying that between the two claims there is almost 81% chance that the waiting time will be more than 3 months. So below 3 months the probability is around 19%. So this problem should give you a complete insight into, if at all there is a question relating to Poisson distribution, right? Finding out the probabilities and all associated with the Poisson distribution, or the wait times between the two events in a Poisson distribution, which will follow an exponential distribution. You should be comfortable in solving questions of these type, right? Then, okay. So the next one, simulate. Now this is the question to do with your random numbers. Simulate two observations from the distribution where the probability density function is 50 by 5 plus x whole cube. So this is my density function. 50 by 5 plus x whole cube. Right. Now, if I want to find out, so first thing for me is, from the density function, find out the cumulative distribution function. Anything where I have to talk about using random numbers or things like that, I need to find out the distribution, cumulative distribution function, and then I will equate it to the random numbers which he has given. But I will not equate this density function value to that. So I have to integrate it. So what is the integration that is coming out when I integrate this? 50 by 50 plus x whole cube. I have to integrate this, and this integration will take me to, right, this integration will actually give me the value for the probability density function, distribution function, and this, whatever the integration of this, I will equate it to the random variable. So if he has given a density function, you should convert it into a cumulative distribution function by doing an integration over this entire area. So I'll do it from, let's say, 0 to x. I am doing the integration from 0 to x for this particular variable. So how do I do it? X is greater than 0. 0 and infinity, when you do it, you will get it as 1. In the whole region, if you are doing any integration, the sum of that will always be equal to 1. Right? Probably when you integrate this, we'll try both of them. So 50 by 5 plus x whole cube. Integration if you do between 0 and infinity. Right? See, there is a scenario like, okay, 5 plus x whole cube. So if I replace, let's say, 5 plus x equal to some t, then this is dx. Dx will be equal to dt. So what I will do, 0. So here 5 plus x equal to t. But when x equal to 0, t equal to 5. So here instead of 0 to infinity, this will become 5 to infinity. 50 by, instead of 5 plus x, I will write t cube. So because this is t cube, I can write it as t power minus 3 into dt. So the integration of t power minus 3 is t power minus 2 by minus 2. This I will integrate it between infinity and 5. So minus 25 into infinity I will ignore, into minus 5 power minus 2, which is 1 by 25, which is coming out to 1. Then only it's a probability distribution. First of all, if I integrate it in the whole region, if the probability comes out to 1, then only it's a probability distribution. Now if I want to find out continuous distribution in any case, because continuous is not up to everything, no? It's like up to some number, up to 2, up to 3, up to 4, up to some x. So I don't, so right from 0 up to some x, what is the total area or what is the total probability. So for that what we generally do is 0 to x, any continuous distribution if someone is asking, either it is from the minimum limit up to some x, I am doing an integration for 50 by 5 plus x whole cube. Or it's as good as just as we have discussed, this would be from, if I assume that 5 plus x equal to some t, dx, the derivative of left hand side, the derivative of right hand side equal to this. So instead of dx I can substitute dt. Even the limits also I have to change. Instead of 0, I'll convert it into the equivalent t, which is 5. Right? Instead of x, it will be 5 plus x. This part is fine. Instead of x, in that 5 plus x equal to t, I'll put both the limits. If I am putting x equal to 0, t is becoming 5. If I am putting x equal to x, t is becoming x plus 5. So the limits are changing from 5 to 5 plus x. 50, because it's a constant, it is kept as it is. By 5 plus x, because it is t, it becomes t cube or t to the power of minus 3. And dx, because it is equal to dt, I'll take it as dt. So overall what is it becoming? 50 into t power minus 2 divided by minus 2. This I am integrating between x plus 5 and 5. Right? Which is nothing but minus 25. The outside bracket is minus 25. Okay, and here what is it is? X plus 5 to the power minus 2. Correct? Minus 5 to the power of minus 2, which is 1 by 25. This is what is my integration. This is what is f of x. So probably if you want to simplify, it is nothing but minus 25 by x plus 5 whole square. And if you go inside, it is 1. So probably you are calling it as 1 minus 5 by x plus 5 whole square. Just to test it out, what you can do is take the differentiation of this. You should get that value. But yeah, if you are comfortable with the integration, you don't need to do that part also. So you are getting it as 1 minus 5 by x plus 5 whole square. That is your f of x. Up to here it is fine. Now if he is giving some random number, asking you to generate. So if he has given, let's say random number is 0.8. So all you will do is 0.8 equal to 1 minus 5 by x plus 5 whole square. From here you can find out what is the value of x. X is something that is following, you are going back and simulating a value corresponding to that particular distribution. Right? So if at all x is coming out like this, so it is nothing but 5 by x plus 5 whole squared is equal to 0.2. 5 by x plus 5 equal to square root of 0.2. Right? So all you can do is square root of 0.2. This is 5 by x plus 5. So x plus 5 by 5 is 1 by this. So 1 by this is x plus 5 by 5. So x plus 5 is 5 into this. This is x plus 5. X is nothing but this minus 5. So the corresponding value of x is 6.18, going with that distribution. So which means the x value, the random variable is taking a value equal to 6.18, going with this kind of a distribution. So simplicity for us is, if someone is asking me to simulate values given random variables, I should follow this kind of a process. So yeah, simulate two observations from the probability from the distribution with a probability density function f of x equal to this much, right? You integrate it, make it a cumulative distribution function, use the random numbers 0.863 and 0.447 in the particular interval. So all you are doing is f of x, whatever you are calculating, you equate it to 0.863. Find out the value of x. You equate it to 0.447. Find out the value of x. That is how you are simulating the values of x from that distribution, which follows that shape. I don't know what is that shape, but the value which I am generated, that 6 point whatever we got, it belongs to that particular distribution. See, the area under that graph is 1, which we have already seen. When I integrated it between 0 and infinity, the area has come out to 1, right? When I have integrated it up to some x, see, he wants me to find out if the area is 0.863 for that particular distribution, where will the area, see, up to infinity, if I am integrating it, the area is 1. Now my requirement is, up to what should I integrate it so that the area is 0.863. Right? When you have integrated it between 0 and infinity, so he is giving some random values. So tell me, at what value of x, which is nothing but at what value up to integration, up to what value of integration will my area be 86.3%? If it follows a 50 by 50 plus x whole cube kind of a shape, if the graph follows a 50 by 50 plus x whole cube kind of a shape, from 0 to infinity, if I take so it is some shape, 50 by 50 plus x whole cube, it's actually some shape. Now the question is, or probably let me do slightly more better for you, easy to understand. Once you understand one, it becomes, see, the graph is like this, 50 by 50 plus 5 plus x. Okay, 50 by 5 plus x whole cube. This is 50 by 5 plus x whole cube. Now if I try to plot this graph, this is the typical graph, right? Now what he is saying is, take the area right from the beginning till the last. The area is from this axis, whatever is inside, right? Whatever the inside that graph, whatever almost the closing is happening with the axis. The inside part, not the outside part. The inside part is the area. Now our integration has said that the area is 1. If I have integrated between 0 and infinity means, the area, if I take the area of this graph between 0 and infinity, it is equal to 1. Now he is saying, tell me what is that area. Tell me what is that area which is up to 0.86. So probably it's like this. If you look this back, okay, these two 0.63. 0.87, somewhere here. So you may simply say probably up to 3 or 4, my area is equal to 0.863. That is what you are doing by doing this kind of an integration. So up to what area is this equal to 0.863? The area is what, because the whole area is 1, I am using some kind of random number. See, what is the random number doing? Okay, take some random number between 0 and 1. So if the shape follows this kind, what is the corresponding value of x where the area will be equal to 0.86? So if for x equal to 3 or something, the area has come out to 0.86, then it means it is following more or less this kind of a shape only. Right? So randomly we are taking some numbers, assigning it to this distribution and trying to find out the corresponding values of our x. So whenever any random numbers are given, see, in the real world it is nothing but we are trying to simulate the data from the original. Right? Just a while back I was doing one practical question. I was trying to simulate the cricket scores of Sachin Tendulkar based on whatever are his averages and the variance in the data and all, trying to fit his scores to an exponential distribution. And based on that, I want to find out what is the chance that he can score a double century or something. Or for that matter, any player, what is the chance that they can score a double century in a match? So what we are trying to do there, simulate some kind of random numbers. Probably he may or he may not have scored a double century. Right? So if I go only with the past data, I may not get an answer that he will score a double century at all. But if I am trying to fit some kind of a distribution to it, simulate the values, there is some kind of a chance, probably it may say there is a 0.001% chance that he may score a double century there. Though he may not have done it today, there is a chance that he may do it slightly later in future. There is a chance for him, whereas for someone else that chance could be very much slimmer. Right? Okay. Now the question, next one, calculate P of x greater than 5 given that x is already greater than 3. So you can very much find out P of x greater than 5 by P of x greater than 3. Right? How am I finding P of x greater than 5? It is nothing but integrated between 5 and infinite. Integrate that value between 5 and infinity, which will give you P of x greater than 5. Integrate it between 3 and infinity, it will give you P of x greater than 3. Divide one by the other, you will get your value. Is this fine? All right. Yeah, now look at the next one. An actuarial student has said that the following 3 distributions are the same. Chi-square distribution with 2 degrees of freedom. Chi-square distribution with 2 degrees of freedom. 2 degrees of freedom is same as gamma distribution with alpha equal to 1 and lambda equal to half. Chi-square distribution, if lambda equal to half, then the gamma will become chi-square with 2 alpha degrees of freedom. So because he said it is 2 degrees of freedom already, I can write it as gamma 1 comma half. Right? Okay. the exponential distribution with mean half. When is it an exponential distribution? If the alpha equal to 1 in a gamma distribution, if alpha equal to 1, it becomes an exponential distribution. So this is an exponential distribution itself. What is the mean of exponential distribution? 1 by lambda. 1 by lambda is the mean of exponential distribution, which means it should be 1 by half. 2 should be the mean of the exponential distribution. So this statement is slightly wrong. The mean is not 1 by 2, the mean is half. Sorry, mean is not 1 by 2, the mean is 2. The gamma distribution with alpha equal to 1 and lambda equal to 2. That is true. So the first and third statements are correct, whereas the second statement is slightly wrong. If we had made that the mean equal to 2, then he is pretty much right. And for the gamma distribution also, the mean is, for the chi-square distribution also, the mean is 2 only. The degrees of freedom is the mean in case of chi-square distribution. So these commonalities and these associations, if you are able to interpret it correctly, you can solve good number of questions. Probably because, see, most of the time it's the usage of logic which is very much important rather than a very longer way of solving the question. And to a large extent in our exam, the gamma distribution gets translated into a chi-square distribution itself. Okay, suppose the continuous random variable x has uniform distribution on the interval 1, 6. So it is following a uniform distribution. Find the probability density function of the random variable y equal to x by 6 minus x. So if you have to find out the random variable y, it is nothing. So x is uniform distribution between 1 and 6. It is a continuous uniform distribution between 1 and 6. Right? So it's as good as saying 1 to 6 f of x dx is equal to 1. If I integrate that continuous distribution between 1 and 6, I will get it as 1 itself. The integration, if it is a continuous distribution between 1 and 6, it means that total area between 1 and 6 is equal to 1. Because it does not take any value beyond 7, 8, nothing. In that 1 to 6, the whole thing is lying. So the whole area under 1 to 6 is equal to 1 itself. Now he is asking me for y equal to x by 6 minus x. So all I may have to do is express y in terms of x and then do the integration part. Right? Because when I am integrating it, integrating the x between 1 and 6, whatever the f of x, whatever is that uniform distribution, and I can very well say the uniform distribution is nothing but 1 by 5. Even that also comes out. The uniform distribution is nothing but 1 by 5. Because if I integrate this 1 by 5 over 1 and 6, see the probability density function in case of uniform distribution is 1 by b minus a, which is nothing but 1 by 5. Or simply to check it out, you integrate this between 1 and 6, you integrate 1 by 5 dx. which is nothing but x by 5. You substitute 6, you substitute 1. 6 by 5 minus 1 by 5, which is equal to 1 itself. So, my distribution function is 1 by 5. Now I am writing y equal to x by 6 minus x. Right? So, it's as good as when I am integrating x between 1 and 6, 1 by 5 dx. Now what do I need? I need to find out p of y less than or equal to y. Y is for me is 6 by 6 minus x less than or equal to y. Right? Or probably p of y less than or equal to 6 by 6 minus x, because y is 6 by 6 minus x. Right? So, based on this, I should be able to establish. Okay, so here I have to write it in form of x. So, if I write this p of 6 minus x by 6 greater than or equal to 1 by y, I can write this like this. Again, p of 1 minus x by 6 greater than or equal to 1 by 5. Now I can simplify it to saying p of minus x by 6 greater than or equal to 1 by y minus 1. P of x by 6 less than or equal to 1 minus 1 by y. So, p of x less than or equal to 6 into 1 minus 1 by y. So, it's as good as integrate this between 0 and 6 into 1 minus 1 by y, 1 by 5 dx. Got this? You have to integrate it between, because you are saying y less than or equal to y, you are finding out the continuous distribution function. Right? So, you are doing it because y is 6 by x minus 6 minus x. You have done this entire process and you have expressed that in form of x. You have expressed the y in form of x. So, it has come out that x is less than or equal to 6 into 1 minus 1 by y. So, x is less than or equal to x means it's like integration between 0 and that value. Right? So, you are integrating the x between this particular limit, which is nothing but 1 by 5 into 6 into 1 minus 1 by y. This is the value. If you are integrating 1 by 5 between 0 and 6 into 1 minus 1 by y, you are getting this as the solution. Right? So, this is what 6 by 5 into 1 minus 1 by y. This is what is your integration value for f of capital F of y. But he is asking you to find out the density function f of y, which is nothing but you differentiate this again. So, 6 by 5, if I write it 6 by 5 minus 6 by 5y, the differentiation part of it is this becomes 0. and minus 6 by 5 into 1 by y is minus 1 by y squared. So the differentiation becomes 6 by 5y squared. 6 by 5y squared is your probability density function. So if you want to write that y in place of x by whatever, x by 6 minus x, you substitute in place of y, x by 6 minus x, and that is what you will get it as your probability density function. So probably it becomes 6 by 5. You can simplify it. So this is nothing but y squared means 6 by 6 minus x whole squared. So some simplification can happen. So you can plan out on that simplification part. So anytime he asks you, simple, anytime he gives you one distribution and asks you, go back. The process is simple. Probably one or two numericals if you do, it becomes more easy. Anywhere he asks you, he gives one distribution he gives and asks you to find the random variable or probability density function for other. Simple thing is, you know this has to be integrated between 1 and 6. Right? Now, if y is this, first find out the cumulative function of y. Cumulative function of y is y less than or equal to some y. Now y means x by 6 minus x. Express that in the form of x. X less than or equal to something. X less than or equal to something means it's nothing but integration of the distribution function of x between that interval. Integrate it, whatever the value that comes out will be the probability distribution function of y. Probability distribution function of y is this much. So take the differentiation back of it, it will give you the probability density function of y. Again, in the third chapter also we'll take up, because this is a third chapter related question, where you will find the probability density and distribution functions of some other distributions. We'll take one or two more examples. But remember, if one distribution is given and you are asked to find out the probability density of some other distribution, where the relationship between y and x is given, this is the process that we typically proceed. The limits have become 0 to in the calculation taken 0 to 6. I have to take it between 1 to 6. Yeah, 1 to 6. Because the continuous distribution is between 1 and 6. So x takes the value between 1 and 6 into 1 minus 1 by y, not from 0. Interval, the lower interval will not change. See, what is that we are saying? Forget about the original distribution. The original distribution, I know that capital F of x is equal to integration of 1 to 6, because it's an uniform distribution, 1 by b minus a dx. Right? The original distribution, f of x. So I am saying f of x is equal to 1 by b minus a from 1 to 6. Or instead of 6, if I take x, I will get 1 by b minus a integration between 1 to x. Because if I do it from 1 to 6, I will get 1. So I am doing it between 1 to x to get the distribution function. So it is nothing but this is becoming 1 by b minus a into x minus 1. Right? Because this is nothing but the integration of 1 by b minus a is nothing but x. X I am integrating between, if I take the limits x and 1, it becomes x minus 1. Right? So the f of x here is nothing but x minus 1 by 5. Capital F of x is nothing but x minus 1 by 5, because b minus a is 5. X minus 1 by 5. Now he is asking, forget about it then. Now he is asking me to find out p of y. So I am trying to find out first f of y. What is the meaning of f of y? F of y less than or equal to some y. What is the value of y here for me, capital Y? X by 6 minus x less than or equal to some y. Some y means some number. Now if I can write it as x less than or equal to some number, it is nothing but f of x. Right? If I can, instead of x by 6 minus x, if I can do some kind of jugglery and try to write it in the form of, probably like in the form of x less than or equal to something. Like first I am taking the reciprocal, 6 minus x by x greater than or equal to y. Probably is also as good as saying 6 by x minus 1 greater than or equal to y. So probably going with saying f of 6 by x greater than or equal to 1 plus y. X by 6 less than or equal to 1 by 1 plus y. 6 by x less than or equal to something. So finally I am able to write this as f of x less than or equal to something. Right? X less than or equal to something is nothing but the cumulative distribution function of x, which is nothing but x minus 1 by 5. Right? So if I am getting here p of x less than or equal to, probably x by 6 is less than or equal to 1 plus y, 1 by 1 plus y. So x less than or equal to 6 into, so 6 by, let's say 1 plus y. X less than or equal to 6 by 1 plus y. So which is as good as f of x here. Right? So instead of x I will write it as 6 by 1 plus y. So I will write it as 6 by 1 plus y minus 1 by 5. Which is, this is the probability distribution function. Which is nothing but, probably if you want to simplify, you can simplify it. 6 minus 1 minus y. So 5 minus y by 5 into 1 plus y. Something like this. So instead of y, if you want, you substitute x back. This is f of x. But you want p of x. Take the differentiation of that. You will get your p of x. Getting it? Any of this type of questions in some form, you will again have them in the practice questions also. So just if you quickly go back and look at there, you will find a clarity on that. Right? So these are some of the most important questions which we can look at as far as the continuous probability distributions are concerned. Right? So you may have to be comfortable in terms of using that 5-6 different types of distributions and some basic levels of integration. So at least at this level, if the practice is comfortable, you should be able to solve a good number of questions. Fine. Sorry. So what is the way where the y is applicable? So any of the x has to be, so it is from 1 to something, right? That is the range for which it is valid.